Hi, Assalamualaikum. So this is an example of a calculation for designing an isolator. So you have a washing machine of mass 50 kilogram operates at 1200 RPM. Find the maximum stiffness of an isolator that provides 75% isolation and assume damping ratio of isolator is 7%. So most of the questions, first thing, make sure you write down what are the given parameters in terms of variables, so it's easy for you to match with the list of equation. So 50 kilogram is the M, 1200 RPM. You have to convert it into radian per second, which means you have to times with 2 pi over 60. It says here isolation is 75%. That means your isolation effectiveness is 75%. So you may want to check it in terms of transmission ratio. Write it in terms of transmission ratio, which is 0.25. Then you have your damping ratio is 0.007, which is equal to 7%. Okay, so you have all these parameters. Then you go to your list of equations, or previously you have this transmission ratio equation. So actually you equate it with 0.25. So your zeta is 0.07, so just substitute and you are left with your omega over omega n, which you want to solve for. So once you get your omega over omega n, you can actually calculate that, and you find that the positive root of your omega over omega n is 0.28. So you're going to get two answers. One is positive root, one is negative root. So once that, you know that your omega is given, okay, which is 1200 RPM. You convert it into radian per second just now. I did that. Then you can just, from the frequency ratio that you found just now, you can just substitute into the formula of your R, frequency ratio. Then you get your omega n is 55.1. So it's easy because isolators model is basically using single degree of freedom system. So from there you know that your omega n is equals to square root of K over M. Okay, since you get your omega n, you can calculate your K. So K is actually 151,000 1.52 basically mega Newton per meter. Alright, so that is how you get your stiffness for your isolator. So that is example 1. So let us take a look at example 2. Okay, in this example 2, let us take a look at this problem. You have a 15 kilogram precision instrument. To be installed on a factory floor. Okay, due to operation of a nearby rotating equipment, the floor vibrates with the frequency of 3500. So basically you can see that the vibration comes from the floor, yeah, not by from the instrument. So you can see that it is actually given in this problem is basically a base motion problem, which is the second case. So I've drawn the figure here. Okay, you can see that 15 kilogram is the mass, and then you have omega, okay, which is input to the system here. So we have the omega is actually 3500 times 2 pi over 60. Then they give you, oh yeah, it says here amplitude of 3 mm. Okay, so amplitude of 3 mm, that means your y is equal to 0.003. So because it refers to the vibrating floor, So that y basically 0.003, and you have your omega is 3500 rpm. So you are asked to propose a vibration isolator so that it will not subject to oscillation greater. So you don't want the precision instrument to have an acceleration of greater than 39.24. So we take that as the amplitude, yeah, capital X double dot, basically 39.24 meter per second square. And then they give you the damping ratio. So I put here the damping ratio. So hopefully we get all the parameters. And what we want to find, basically here, we want to find, so we also list out the things that we want to find. So it says here there are three things that we want to find, which is the maximum displacement of the instrument. So take note that displacement of the instrument is x. So the maximum displacement is the amplitude itself, which is capital X. Required stiffness of the isolator, okay, which is K itself, and static deflection of the isolator. I put there the notation of static deflection, xk and delta st. Okay, so those are the three things. So we know that we have all these parameters. So we can actually, first of all, we can change the units of omega. We have it in radian per second now from the 3500 rpm. And then they give you the acceleration just now. From that information, you can actually get the capital X, which is the first things that you want to find. Okay, they ask you of the maximum displacement of the precision equipment, yeah, because you already have your omega. So from x double dot, if you remember the relationship of your x double dot is equals to omega square capital X. Relationship between acceleration and displacement. So you've done with that, the first question. And then you use the transmission ratio equation of the forcing frequency to the natural frequency. Because here you want to find the K. Remember, you want to find the K, so you have to find the omega n. So you use the displacement, okay? We do here is not force transmission ratio, but it's displacement transmission ratio, or your TD. Okay, so in that case, you can actually calculate, because you have your capital X just now, okay, which you found in the first part. Then you also have your capital Y. So that's why you can get this TD. So in this problem, it's slightly different. You don't have the isolation efficiency, but they give you the capital Y, and you have to calculate capital X. So once you get that, you can solve for the R, which you can get your omega n. So from there, you get, since you have omega, you have R, you can calculate your omega n. So once you can calculate your omega n, so this is quite similar to in example 1. Once you get your omega n, you can get your K. So you've done with part 2 of these questions. They ask you about what is K. So once you got your K, you have the relationship between static deflection and also your K. Okay, so where your omega or your mg equals to K static deflection. So if you remember this equation in your early or beginning of the earlier in the beginning of the semester, we have this equation to get your static deflection. So this is actually question part 3 of this question. So you can calculate your static deflection. So easy peasy, you just using the equation transmission ratio, and based on the parameters given, you can find all those three information.